So, hello everyone. I am Dan. I am a customer reliability engineer here at Jetstack. It's a mouthful, so we often abbreviate it to CRE. And joining me today is Alex Wootton. Alex, would you like to introduce yourself?
Hey, yeah, sure. So I'm a field engineer, a solutions engineer in common parlance, but in the Jetstack world, I'm a field engineer, which just means I'm out in the field working with clients, yeah, helping them solve whatever kind of technical or mostly technical problems that they're facing.
Cool. And what are the what are the strangest challenges you see clients have these days?
Well, I'll preface this all by saying I've had exactly one client at Jetstack so far, um, but strange problems. I'll say so far they've been fairly tame actually. As far as as much as the kind of um, problem space is fairly bleeding edge, like using Kubernetes clusters, kind of moving the cluster itself into the castle rain, right? So we're kind of creating and destroying clusters like they don't really matter to us. That's kind of a new step for me. So that was um, pretty interesting. Um, but as far as weird is concerned, there hasn't been anything super strange. There was certainly nothing that was like a massive head scratcher there where I was like, like if anything, it's been more cases where you ask yourself, why are we doing it this way? Why are we using a serverless Lambda to do something that we could do very easily by extending Kubernetes, for example? So yeah, nothing super esoteric or strange. It's rather boringly, I'm afraid. Yeah, I wish I had a better answer for that one.
Yeah, cool. So with this client, like, there's nothing massively strange going on, but what are the key projects you're kind of helping them with?
Yeah, so to talk abstractly, I guess, because we're not going to get into the specifics of who I've
Hmm.
been working with, but so the client I've been working with is trying to do a bunch of different stuff. They have firstly tried to abstract away the kind of creation of Kubernetes clusters on bare metal kind of servers, specifically housed in server farms. So not the ones that they have in house necessarily. They're then abstracting away their own creation layer into another layer that means they can kind of create clusters through many different engines, including their own. So kind of GKE, EKS, and then their own kind of orchestration layer for creating Kubernetes clusters. And then on top of that, they've built an orchestration layer allowing customers to deploy kind of whatever workload they want, whatever Docker container they have basically, into these Kubernetes clusters that they can create kind of anywhere, in any shape, on any cloud, right? So they're building their own kind of very specific container deployment platform. And yeah, I mean, and they're doing it all using serverless technologies in AWS, which has been super interesting. So it's kind of a reconciliation pattern, which you'll commonly see in Kubernetes. You know, that's the main kind of loop in a Kubernetes cluster. You create a resource, and then the Kubernetes API will go and try to create it, try to kind of make it real. And we built that several times using Lambdas and DynamoDB in AWS, which was not what I thought would be the easiest, quickest way to do that, but it certainly taught me a lot. I've not worked in servers before, so that was a really interesting kind of problem space, definitely.
Nice. Do you think, like, how common do you think this pattern is? Maybe just hypothetically.
Yeah, outside of this one customer, I've not come across it before. I'll say not in previous roles. Um, I wouldn't be surprised if it did take off though. The main reasoning for doing it that way and not running long-lived Kubernetes clusters and doing it that way was that they didn't want the management, they didn't want the maintenance kind of overhead of having to manage long-lived Kubernetes clusters. And depending on the situation, I can really see the appeal there, right? If you can afford to spend the development time and to engineer your software in such a way that takes advantage of kind of serverless, then I think there's a real, especially if you're not, if this is like a greenfield or a kind of unproven product, you don't know what your throughput's going to be, you can't kind of plan for it, and perhaps it's kind of, you're just testing the waters, it makes absolute sense to try to do something in serverless where you kind of, you're only paying for what's being used, right? Makes perfect sense. So I can see it becoming more common. Whether the reconciliation pattern was the best way to go, I guess TBC. Maybe hopefully I'll get to kind of come back and work with them at some point again in the future, and I'll be able to report back as to how well that's gone for them versus kind of a more synchronous transactional model. But for all intents and purposes, I mean, it gives a good user experience up front, in so much as, we do very little validation on the front beyond kind of what is absolutely kind of makes sense as far as like what we can accept in the form of what a good request is for the API, and then we try to provide kind of good contextual information about how to change your spec, what your object, what your resource spec is, but in a very Kubernetes-esque way. Honestly, like we had a very strong kind of pool of inspiration from the way Kubernetes runs to kind of design the states and statuses and error messages and kind of ways that we report that state back to the end user. And it's certainly not simple, as we learn, but yeah.
Cool. So you said they thought it was a good idea to put the effort into building this rather than maintaining long-lived clusters. Do you see sort of like cluster maintenance being a fairly decent obstacle for many people?
Yeah, I think so. Especially, I guess it depends on the structure of your teams, but I think in a cross-functional team, there isn't a huge appetite for individuals wanting to be responsible for maintenance. Maintenance is probably the least exciting problem to solve in many cases, and so my experience is that if you have a team of engineers given enough time and resources, they will generally try to lower the maintenance as much as humanly possible. Sometimes to a fault, sometimes to the point of kind of really defensive programming and observability, trying to kind of make sure that you're alerting on every single little thing, and that you can kind of trying to preempt, every possible problem. But absolutely, it does seem that maintenance tasks are largely wanting to be kind of automated away, just because, very few people want to follow a run book on how to kind of upgrade a Kubernetes cluster, especially let's say you've got 60 Kubernetes clusters and they're all running different versions of it's much more fun to try to come up with a way to automate that than it is to sit there and manually of go through the process of updating each one, right?
Yeah, I've had a few subscription clients. Maybe some clarification needed there. Subscription is a service-based product from Jetstack, where we help with proof of concepts and support around Kubernetes. We've had a fair few like on-premise Kubernetes clients that have sought our help automating away like on-prem, like physical hardware cluster maintenance. I mean, most of the time, the simplest answer has just been Ansible. Nothing quite as fancy as serverless cluster automation. But yeah. So other than cluster automation, what do you think the biggest obstacle your client faced during the engagement?
Honestly, product direction. There was very little of it. Considering this particular client was trying to replace an existing product in their portfolio with something based on more modern, better supported tech. The previous solution was based on Docker Swarm, which around the time of engagement with us, Docker Swarm had recently been end of life, effectively no support beyond a certain date. I think maybe even the end of this year, 2021. And so we're trying to kind of build something with a more solid, modern kind of supported foundation, but also learning a lot of lessons from that previous product. But I think that meant that they brought with them maybe one too many assumptions about how the new product needed to work. Certainly a lot of kind of challenges around naming conventions. We kind of were forced in the end to adopt existing naming conventions that kind of confused confused the project a little bit early on. Thankfully we did manage to settle on some kind of sensible names, but it's amazing how overloaded terms can really stifle communication, right? They made it really hard to talk about our ideas and kind of possible solutions when we had a bunch of overloaded terms that were being thrown around, so you never really knew exactly what was being discussed or which part of the stack was kind of under question, or whether we're talking about the old product or the new product. That was a challenge for sure. And then later on, kind of around questions such as, how cheaply do we need to be able to run the system? How many people do we expect to be able to serve? What kind of customers are we expecting to have on the product? Some fairly fundamental stuff, and it was sometimes shocking how little was known around those, and it actually kind of transpired that the approach was more to build the technology and kind of figure out how to sell it and how to kind of mold it later to the kind of marketplace as it emerged, which was new to me, and something that took me a while to get comfortable with, but was definitely still had its upsides once you got used to it.
Cool, fantastic. Well, I think that about wraps us up. Thank you for joining me today, and hopefully we can have you back on at some point.
Sounds great. Thanks, Dan.
Cheers. Good day.